Puerto Rico is divided into three main geomorphological regions: the mountainous interior, the coastal plains, and the northern karst terrain featuring haystack-shaped hills, crater-like sinkholes, and one of the largest river cave networks in the hemisphere. For centuries, the karst region was inaccessible to all but isolated farmers, who never imagined that one of science's most ambitious ventures would connect this marvelous landscape with rotating planets and distant galaxies. In the late 1950s, Bill Gordon and a group of young engineers and scientists from Cornell University dreamed of building a radio telescope on a scale so large, so precise, and so sensitive it could pick up signals many billions of kilometers away. They decided on a remote site south of the Puerto Rican city of Arecibo, and construction began. 3 years later, in 1963, the William E. Gordon telescope was inaugurated, and scientists detected the first radio waves.
Originalmente, radar se construyó para estudiar la ionosfera, que es una región de la atmósfera superior. A la vez que se inauguró, se dieron cuenta que tenía mucha utilidad para estudiar objetos en el espacio, o sea, objetos astronómicos. Y de igual manera que se estudian con telescopios ópticos, que son los que la gente se imagina más comúnmente cuando piensan en un telescopio. Nosotros los observamos en las frecuencias o largo de onda de radio.
Low-frequency radio waves radiate from all objects in the cosmos, moving basically at the same speed as higher-frequency light waves, 186,000 miles a second. They travel in all directions through empty space. When they reach Earth, they are no more noticed than the air we breathe, unless they are collected by an instrument such as the Arecibo dish, the world's largest and most sensitive telescope. Maintaining the telescope's platform requires high-wire skills and nerves of steel.
Me encuentro en la U2 haciendo la inspección y todo está normal, está perfecto.
Una de las grandezas del radiotelescopio de Arecibo es su sencillez estructural, que lo convierte no tan solo en el más grande, sino también en el más sensitivo del mundo. Su plato esférico colgante, su triángulo que se sostiene de 3 torres por cable, su anillo por donde nosotros entonces movemos nuestros receptores, y el arco que nos da entonces el otro ángulo de azimuto sobre el cielo, nos convierte en uno de los más importantes instrumentos del mundo.
The telescope's 20-acre reflecting dish is 1,000 feet, 305 meters in diameter, and made up of almost 40,000 panels individually adjusted to maintain its spherical shape. 450 feet, 140 meters overhead, a 900-ton platform hangs by cables from 3 concrete towers. Suspended from the triangular platform is a Gregorian reflector system. Since the dish remains stationary, the telescope's pointing is done by moving the feed up to 20 degrees from a vertical position. The main dish reflects radio waves coming from space and directs them to the Gregorian system. Once detected, the signals are amplified by receivers, cooled to near absolute zero, then sent through fiber optic cables to the control room, set in a small building wedged between karst hills at the edge of the dish. In the control room, the signals undergo more transformations as they are filtered, converted from analog to digital, sampled, and stored on the hard drive of a computer. Once the data is stored, scientists use computer programs to make images, prepare maps, analyze their findings, and publish the results. Because of the size and sensitivity of the telescope, radio sources that may require several hours of observations at other radio telescopes can be done here in mere minutes. As the dream of the observatory became reality, scientists from around the world came to Arecibo to see what they could learn through the telescope.
What makes Arecibo Observatory unique among the great observatories in the world is that we do 3 fields of science, and we do it with a precision and sensitivity that's unmatched by any other observatory. Those are astronomy, radio astronomy, planetary astronomy using the radar, so it's radar astronomy, as well as upper atmospheric science, and in fact atmospheric science from the surface of the Earth through the outer reaches of space.
Atmospheric scientists study the inner and outer layers of the ionosphere, a region roughly 100 to 800 kilometers from Earth.
We live on the surface of the Earth, and the lower atmosphere is most relevant to our lives. That's what we breathe. If we want to understand global warming, climate change, we need to study the whole atmosphere in order to understand whether our models are making a proper representation of the atmosphere as a whole, and then come back to how that affects us.
The middle atmosphere is studied at the observatory's LIDAR, Light Detection and Ranging Lab. The LIDAR, set on a nearby hill, sends out a narrow, coherent beam of visible laser light into the nighttime skies, and scientists study the returning reflections. Climatology data measured here is helpful in the understanding of natural events such as the movement of Sahara dust, which can cause asthma and other health problems. Planetary astronomers map planets, comets, and asteroids. The Arecibo Observatory radar is also the world's most powerful instrument for identifying and studying the orbits of near-Earth asteroids.
We're one of a very few places on the Earth that can take actual pictures of asteroids. We can measure very precisely time and speed. So we send out a pulse of radio waves, and very powerful pulse of radio waves. It bounces off the asteroid or the planet or whatever we're looking at, bounces back, and just before it gets back, we turn off our powerful radar transmitter and turn on a radio receiver and collect the echo. We measure how long it takes that light to get there and back. Then what we usually do is take those images, and in a computer model, we'll make a 3D image like you'd really see if you were there. And this is an example of one of these, what this asteroid would look like from different directions if we were looking at it with our eyes.
Over the years, radar scientists have worked closely with NASA.
For example, about 10 years ago, the SOHO spacecraft had a problem, and they asked us to measure how fast it was spinning. And as I said, Arecibo measures speeds of things. So we said, we can measure how fast it's spinning, because they wanted to know if it still had any fuel left or not. And if it had used all its fuel, it would be spinning very fast. Otherwise, it wouldn't be. So we were able to measure where it was and how fast it was spinning and answer that question for them. And they discovered that the spacecraft was actually in good health, and they were able to recover it, and it's still taking pictures of the sun today.
Radio astronomers analyze radio waves that arrive from hundreds of millions of light years away, whose signals are far too weak to be detected anywhere else on Earth. Some of the observatory's most important discoveries relate to pulsars, rotating neutron stars that have collapsed into small, dense objects mere kilometers in size.
One unique property of pulsars is that they're extremely accurate natural clocks. Pulsars got their name because they're observed as radio lighthouses, essentially. When the first pulsar was discovered in the 1960s in Great Britain, people thought it was a beacon of an extraterrestrial civilization.
In 1974, radio astronomers Joe Taylor and Russell Hulse discovered a binary pulsar and measured the orbital decay of the binary system, confirming Einstein's prediction of the existence of gravitational radiation. For this discovery, Taylor and Hulse received the Nobel Prize for Physics in 1993. For close to half a century, the Arecibo Observatory was operated by Cornell University. In 2011, operations were transferred to a consortium of institutions, SRI International, Universities Space Research Association, and, for the first time, a university from Puerto Rico, Universidad Metropolitana.
We have the opportunity to combine the efforts of our Metropolitan University and other major academic institutions worldwide with the government in Puerto Rico. We expect to generate new challenges for the Arecibo Observatory by sharing in the future development of astronomy and atmospheric sciences for the benefit of our Puerto Rican youth. The future will be reflected in a new planetarium to be constructed and opened within 2 years as a way to promote local, national, and international tourism.
Since 1997, tourists have learned about the observatory at the Ángel Ramos Foundation Visitor Center. Here, the works of the scientists are accessible to the public. Through interactive exhibits and displays, visitors learn of astronomy in general and the operations and discoveries of the observatory in particular. The Visitor Center receives over 100,000 visitors a year, and some 30% of them are Puerto Rican school children. Through its outreach to the public and its educational projects, the observatory has given and will continue to give many the opportunity to learn about what was once comprehensible to just a few.
El Observatorio de Arecibo tiene mucho que ofrecer a los estudiantes de todos los niveles educativos. Una meta importante que hemos adoptado va dirigida a promover la investigación científica. De esa manera, esperamos desarrollar el interés por el estudio de las ciencias y profesiones que nos permitan adquirir conocimientos del universo.
Children all have fantasies about what they would like to do. They fantasize about being astronauts. Some fantasize about being engineers and scientists and doctors. And I tell them that if you have a dream, don't think it's just a dream. When you're a child and you're dreaming about things, that these things really are possible.
A small group of scientists and engineers dared to dream. As a result, the karst formations cradle the world's largest single-dish radio telescope, linking nature and humanity. This is the Arecibo Observatory, where big dreams have taken us to the ionosphere, the solar system, galaxies, and beyond in our ongoing quest to understand the wonders of the universe around us.